So, good morning everyone, and today we're going to be talking about logarithms. Now, this is a very important chapter in mathematics, because logarithms makes all sorts of calculations, very easy. So, what we're going to do is in today's lesson, we are going to learn, how to solve logarithmic equations. Okay, but before we get started on that, what I really wanted to teach you is what a logarithm really is. So let's get started. So basically, I'm sure all of you understand that you have log base a to the power n equals x. Okay? So I'm sure you've heard of this logarithmic equation before. So now it's actually pretty simple to understand because this is a logarithmic equation. So let's try and understand this. Now, obviously you say log base a to the power n equals x. Okay? So here a is the base, okay? And x is the exponent and n is a natural number. Okay? So I hope you guys understand what a natural number is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, going on all the way till infinity. All whole numbers. Sorry, not whole numbers, but all whole numbers except 0 that go on till infinity are natural numbers. Okay? So, so those are the natural numbers that we have. So now, what we need to do, guys, is we really need to convert this. Okay? So now we need to convert this into an exponential equation. So this will become a to the power x equals n. Okay? So it will become a to the power x, which equals n. Okay? So like I already told you, because we have log base a, log base a to the power n equals x. So a is the base, so that's why it becomes the base here. X, is the exponent, that's why it becomes the exponent here. And n is a natural number, that's why it comes after the equal sign. So because n is a natural number, so what you can assume is that it's not just a natural number, but it's also on the other side of the equal sign. So the natural number is just a way of simplifying the natural number for it to become a second base. Okay? So basically what I'm trying to say is that because this is a to the power x, at the end of the day, n will also become a to the power 1 and a will equal to, and x will equal to 1. So I hope you guys understood. I hope you guys understood this. So now what we're going to do is we're going to move on now. So basically I hope you understood this. So now what we're going to do is we're going to take a few examples. Okay. So say you have log base 2 to the power 32. Okay. So what does log base 2 to the power 32 equal? What does it equal? Do you know what this equals? Okay. So log base 2 to the power 32 equals 5. Okay? So what does this become basically, guys? Do you know what this becomes? It's very simple. Let me just tell you. What this becomes is this, look. So as you know that 2 is the base, so this is 2. 5 is the exponent, so this is 5. Okay, and then obviously you're going to have an equal sign. And then you have 32, so this becomes 32. But then this can also be simplified because this can become 2 to the power 5, which equals 2 to the power 5. Okay? So let's take another example. Okay, let's take maybe log 10. Okay? Log 10 to the power 1000. Okay, log 10 to the power 1000 equals 3. Okay? So how would you write this? How would you write this, guys? How would you write this? This is again very simple. Nothing nothing tricky. As you know, 10 is the base, okay, 3 is the exponent, and then it becomes 1000. And then again you can have 10 to the power 3, which equals 10 to the power 3. So you see, this is a natural number, isn't it? But then it simplifies to become, the same base as log a. That's why I'm saying that this is like a second base. Now, if you're gonna have trouble remembering, second base, then just remember second base like you have in baseball. There's a second base in baseball as well. You can remember this like that, and you can remember this as maybe first base. So if you're someone in the US who plays baseball, I guess baseball has made life easy for you in learning logarithms. So let's take another example. Okay? So now this one is a little tricky, guys. You have log base 3 to the power 81. Okay? So the reason why I'm saying it's tricky is because I'm not really going to tell you 3 to the power, log base 3 to the power 81. I'm not going to tell you the answer to this question. I just want you to guess it by yourself. So basically, if I tell you what it is, it's going to become easy. But that's just how it goes. But okay. So let me just tell you, it's 4. Okay. So now how are you going to solve this? Basically, this is simple. Okay. You have log 3 right here. Okay. Sorry, you have base 3 right here. So this becomes 3. Exponent is 4. Okay. And this equals 81. And then you have 3 to the power 4 equals 3 to the power 4. Okay? This is how it is. This is how it is, basically. Okay? So I hope you're keeping that in mind. Just keep that whole thing in mind, and it will become easier. Okay. So let's take a few more examples. Okay? Now the example which I'm going to take is going to be just slightly a little tough. Okay? Okay, what I mean it's going to be a little tough, like, I'm not saying that it's going to be hard for you to solve, but you see there are certain rules which you probably won't understand, but let's just get to the point. So, say you have log base 7 to the power 1 equals 0. So basically, what is this? Okay, 7 is the base, okay, 0 is the exponent, and 1 is the natural number. So do you see any problem here? Do you see any problem here? In this particular problem, what do you see? That there is a 1 here. So if there's a 1 here, there's nothing that I can do to it exponentially to make it become 7. I can't do anything, because even if I do 1 to the power 0, it's still not gonna, help me, even then the purpose is gonna be defeated. So in a case like this, what do you realize? What do you realize in such a case? In a case like this, what you should realize is that even on this side, you have to have 7 to the power 0. Although it is 7, because remember, even 7 to the power 0 equals 1. Anything to the power 0 equals 1. So that also means 7 to the power 0. So whenever you get a 1 over here, then just look at whichever base is here, and then make sure the exponent to that base is 0. So that's how this will become 7 to the power 0, which equals 7 to the power 0. So 1 equals 1. Okay? So just remember this. Now I'm going to be doing 2 more examples, and then after those 2 more examples, I'm going to be discussing some other important logarithmic rules with you. It will take 2 minutes, and then we will get cracking on logarithmic equations. You know? So let's just do two more examples and then we're going to be ready to rock and roll. Okay? You know, we're going to get cracking on this. Okay. So now you have, okay, log base 81, okay, log base 81. Okay, let me just check the question. Okay, guys, yeah. Okay. So, okay, log base 81 to the power 3 equals 1 upon 4. So basically, guys, these are questions that I've taken from books. I've not made them up, that's why I don't remember them, and I have to keep on looking. Okay, so again, this is very easy. So, again, remember, 81 is the base, okay, and then this is the exponent, okay, and this equals 3, okay. So then I'm sure you know from a previous example that 3 to the power 4 is 81, and then you have 1 to the power 4. So I'm sure you know this rule where a to the power equals mn. Now even if it's a fraction, guys, even if it's a fraction like this, it will still become this. Okay, a to the power n divided by n, you know? I just want you to keep these rules in mind as well. And then, this equals 3. So then 3 equals 3. Okay. So let's take one more example. So the next example I'm going to take, make sure you remember these, these rules as well. Okay? So it is log 128 to the power 2 equals 1 upon 7. Okay? So this is the next example. So again, this is what we can do. Remember, the base is 128, okay? Exponent is 1 upon 7, so this equals 2. And then you can do the same thing, 2 to the power 7 upon 1 by 7, which equals 2. And then as you can see here, this becomes 3. In the same way, that will become 2, and then 2 is equal to 2. I think you can take it from there. I don't need to finish that. So now what I'm going to do is, I'm going to tell you 2 more rules, okay? 2 more logarithmic rules I'm going to tell you. Not 2, like 3 more logarithmic rules that I'm going to tell you. Now this is not going to take a long time. This is not going to take a long time. This is just going to take 2 seconds and then we'll get ready to rock and roll. Okay? So let's do it. So the first one is this. Okay? Okay, log base a to the power 1. Okay? Okay? Equals a. Okay? This is the first rule. Okay, no, sorry. Sorry guys. Does not equal a, it equals 0. Okay? This is the first rule. I don't know how I got that mixed up. So it equals 0, okay? It equals 0. This is the first rule that you have to remember. Okay? This is the first rule that you have to remember. Obviously, you need to remember this, but then after that, you have to remember this. And then another one, which is very simple, is this one. Log a base a equals 1. Okay? And then now one more, which is kind of a bit tricky, but you can do it. It's this one. Log a to the power ax. Okay? Which equals x. Okay, basically guys, this equals x, but people really have, the wrong notion of what this equals. So I hope you understand, I hope you keep in mind these rules. Now what I want to do is I want to show you the equivalent of these rules. So I hope by now you might have written the equivalent of these. So let's just do it. Okay. So a is the base, 0 is the exponent. So a to the power 0 equals 1. Okay, and you can verify that because a to the power 0 is 1, 1 equals 1, it's correct. So this is the basic rule, guys, that this one, guys, because you have, okay, because guys you have, you have this, basically equals a, okay, it basically equals a, okay, that's what it is. This is what that equals, okay. So basically, guys, you're gonna have an x here as well. I'm sure you know that. You're gonna have an x, and then you're gonna have a 1. So basically, this is like that. I mean, this is how you can prove that this is x equals 1. But this is a basic rule, guys. That log base a to the power a is 1. This is a basic rule that you should remember. This is a basic rule that you should remember. So now this one is a little tricky. This one's a little tricky. Why? Because I'll tell you why. So if you want to prove this, then the first thing you have to do is that this is an exponent, right? So there's a rule where this exponent comes on the side like this. Okay? And then what you have left is log base a to the a, and then x, okay, multiplied by 1 becomes x, so the answer is a.